Coulomb's law in vector form. Actually, why many students feel difficult to understand this? So, the reason is, before discussing this Coulomb's law in vector form, you must have the idea of vectors. Otherwise, it is very difficult. Okay, so that's why in this video I need to give some more details about vectors also, right? What the Coulomb's law is dealing with, what it is dealing, because it is dealing with force between the two charges, right? Those two charges are treating like this. It is the charge q1, it is a charge q2. Where are these two charges? These two charges are at some positions. So to identify that position clearly, we have taken a reference, and from that reference, where is the position of q1, where is the position of q2, we can understand. So that if you write in vector form, because position, the displacement you can write in vector form. So that is number one, from the origin q1 is placed at r1, q1 is placed at r1, q2 is placed at r2, So this is the position. But what about the force between these two charges? And we are treating them as positive charges, right? Because sign convention is plus. And what could be the force between them? Definitely it is a repulsive, because like charges. Then what is the direction of that? In the previous video, the Coulomb's law, we have discussed that. The line joining those two charges, right? Line joining those two charges. It is the line along what the force is acting, right? So along this line, what is the direction? It is needed to understand, right? So for this, it is a repulsive. We are saying repulsive means quite opposite one another. It should be quite opposite, right? Quite opposite. So then it is a q1, the force of 1 by 2, and this one is force on second charge by first charge. It is the case. But here the direction, if you are talking about vector, surely it is talking about, it's a direction also, right? It's a direction also. What is the direction of r1? This is. What is the direction of r2? This. What is the distance between q1 and q2? Because always the Coulomb's law is dealing with F equals to k into q1 q2 by r square, right? Where r is the distance between two charges. So what is this r square? So that is very important to understand, because it is in vector form, na? It is in vector form. So triangle law of vectors says that, so em cheptundi triangle law of vectors ante, if three sides of the triangle are representing vector, if two sides are continuous, it is here to here and it is here to here. Two sides of the triangle are continuous, then what is the resultant of these two vector? It is opposite to that direction and remaining third side. What is this side? Suppose let me take A, B, C. So AB is one vector, BC is one vector, and AC is resultant. So that resultant magnitude is AC, direction is this, closing side of the triangle. Similarly, you can understand this. This is the R1, this is the R2. Whenever you are talking about force on 1, 2, means force on charge 1 by second charge. So what is going to be the distance between those two charges? It is going to be in this direction, right? Force is acting in that direction. Then what is the resultant from this triangle? What you can write? What are the what two vectors are in the same direction, continuous? R2 is this direction. And what is the R value? Here we are writing, actually in the formula it is R, but here to understand very easily, from 2 to 1, it is in the direction from 2 to 1. R2 to 1 it is representing from Q1 to Q2. What is the displacement? It is a R2 to 1. But if you come from Q1 to Q2, it is R1 to 2 vector. R1 to 2 vector. But both are direction is opposite, magnitude is same. Magnitude is same. So that's why what we can understand from this, R122 magnitude equals to R221 magnitude, except the direction is quite opposite. Now if you are talking about F122, what you can write? F122 is equals to K into Q1 Q2 by what you write? R square. What is that R here? Is it R122 or R221? Whatever you write in case of magnitude same, but direction is different, right? So but if you see the triangle of vectors to satisfy here to O to Q2 and Q2 to Q1, so that these two are continuous. These two are continuous. So that's why I am going to take R2 to 1. R2 to 1. So whenever you are talking about force, you need to give the two details, because force is a vector quantity. Force magnitude you can identify with this. But if you are talking about direction also, what is the speciality of vector form? Vector form lo em untundi manaku advantage ante both magnitude and direction in a single notation you can represent. That's why you are going to say this is magnitude, but what about direction? Direction is going to be represented with R2 to 1 unit vector representing the direction. So what you can write? R2 to 1 is equals to vector of R2 to 1 by magnitude of R2 to 1. Magnitude of R2 to 1. So this is the form. If you write this here in the very basic formula, so what you will get? F122 equals to K Q1 Q2 by R2 to 1 whole square into, in this form if you write it, R2 to 1, it will be written with the bold letters in the textbook. It is in the vector divided by the magnitude of this one is going to be the same only, right? So that is R2 1. But both are not same, both will not get cancelled, because it is in the vector form, it is in the magnitude. How you say that? It is like 3 I cap by 3, like that it is. So it is a magnitude, both you cannot cancel, right? Similarly these two are different from one another. Then if you write it, what you will get? K Q1 Q2 by R2 to 1 cube power 3 R2 to 1 is a vector. This is a force 1 to 2. It is in the form of vector, because when you write this is magnitude, this up to this it is represent magnitude, this one is going to give us a direction. So force details as a magnitude and direction in the single equation, single form we have written. If you that extend, and you are going to get this way, so what is going to be that one now? It is that. And if you write, okay, force on first charge you are talking, what about force on second charge? Force on second charge by the first charge is equals to K Q1 Q2 by the, similarly when you are talking about force on Q2, from the Q1 you are taking the distance, the what is that? R1 to 2, because from 1 to 2 you are writing. Then R1 to 2 square into magnitude, it is in the vector form, right? Unit direction if you write it, R1 to 2 cap unit vector. So that after simplification you will write it. So F2 to 1 is equals to K Q1 Q2 by R1 to 2 cube into R1 to 2, because this is a in vector form. Can we make them both are equal? Yes, we can make it. Why? Because R1 to 2 equals R2 to 1. Here R2 to 1 cube is there, R 2 to 1 is there, r1 to 2 cube is there. So instead of that, simply for applying the common whether it may be force 1 to 2 or force 2 to 1, you can write it in the form of F equals to K into Q1 Q2 by R cube into R cube into R, where it is R is equals to, what is that, R2 to 1 or R1 to 2. It's a magnitude I am taking as R. So whenever it comes and whenever you are writing this as to understand whatever the position vectors clearly, if AB is R1, if this is R1 to 2, what is going to be this one? Suppose let us say this is R2, this is R1, what is going to be this? Closing vector, right? Again I am remembering you, the triangle law of vector says that if two sides of the triangle are representing in magnitude and direction continuously, the closing side of the triangle is giving us the resultant. So what is, if you understand this, these two are giving us what? R2 plus R1 to 2 is equals to R1. Then what is going to be this? If R1 to 2 equals to R1 minus R2, and what other idea we have already? So if like charges, what kind of force is going to be present? It is going to have, like charges means repulsive and unlike charges means attractive. The direction of force is going to be, if one is a positive, another one is a negative, that condition we can understand very easily. So that's why to understand that attraction or repulsion, Q1 into Q2 is less than 0, means the product of these two, Q1 and Q2, is going to be less than 0. Means what? Any one of these two charges can be negative. So plus into minus, this minus total charge value is less than 0 na? That's why one another opposite. If Q1 Q2 is greater than 0, what you can say? It is the positive, right? So greater than 0 means positive, less than 0 means negative. So what it represents whenever you are talking about like charges and unlike charges, we can understand. I hope that you understand this vector form, right? So how you feel about this class, you can comment, because encouragement is needed even for teachers, because I get some comments from my students. I will give that in the next video, because it gave me lot of encouragement to do the videos in my way of presentation, because you will see that what is that in the next video. Thank you.